Alright, hey guys, this is April 15th, Wednesday, for Algebra 1. So y'all have a quiz today, so I need y'all to work through that. The first 4 on the quiz are just definitional, so you can use your book to get those. The next set deals with the scatter plot. So remember, scatter plot is the list of data that can be scattered up or scattered down or scattered wherever with nothing association. So remember, if it's scattered and it is trending upward, then that is a positive association. If it's scattered and it's trending downward, that is a negative association. If it's just everywhere and it doesn't look like it's going up or down, it's just all out of whack, then that is no association. Or if it's just a steady line across, that's no association. The second thing there, you can actually, on the plot, you can actually find your x and then figure out where it is on the y. If they give you the line of best fit equation, you can plug in the input, which is the x value, and then try to solve for the y. So plug in the number, then use the equation and work it through. And that's pretty much all you're going to be doing there. And so just use the information they give you. If they give you the input and the equation, plug it into the x. If they give you the output, then plug that into the y and solve for x. So it just depends on what they give you, but if they give you the input, then just plug it into x. If they give you the output, plug it into y. And then the rest are just looking at the graph. So that should get y'all started on that. So that is quiz number 32. And so that'll be for that. Today's lesson, once you get done with the quiz, is going to be the probability of a single event. So this lesson is on page 390. So page 390, I have some stuff written on the board, definitions and things like that. The first thing we need to know is that it is in a probability, the calculation, an outcome is a possible result of an event. So the outcome is the possible result of the event. A successful outcome is the outcome that will give the requested result. And then for probability, here's the key definition. The standard definition of probability is the number of successful outcomes divided by the number of possible outcomes. So up here on the board, the probability of an event is the number of successful outcomes over the possible or total number. And so it's what you're looking at over however many total you have. And that's how you set up the fraction. And so the actual, the definition as far as just the letters, the F is the number of successful and the N is the possible. And so it's F over N, the number of successful over the number of possible. And so before we can kind of do any problems, we have to understand a couple things about probability, some rules. And so basically the rules are this. For the probability of an event, P parentheses event, what goes in the parentheses is just what you're choosing. So if we were doing red marbles, then it would be P parentheses red marbles, and that just means P of red marbles, probability of the event. So the rules are the probability of an event has to fall between 0 and 1. So if I said, if I had marbles and I said, what is the likelihood of me choosing a red marble? I have to have my probability has to wind up between 0 and 1. It'll wind up being a fraction the way we do these. And then you can make the fraction a decimal. And if the decimal is in between 0 and 1, then it checks, it works. But you have it, your probability has to be between 0 and 1 of any event. That's the only way we can do it. If it's not, if the probability is not between 0 and 1, it's not valid. Like a lot of people say things like 110% of this, 110% of that, whatever. Technically, as far as probabilities go, that doesn't work. It has to be between 0 and 1. That's the only way to do it. And so 0 and 1 is the definition. All right, now, so the question is, okay, if I got like a fraction of 3 over 5, then 3 over 5 is 0.6, and so that falls in between 0 and 1, so that's valid. Okay, what if I got a fraction that says like 0 over 5? Then 0 over 5 results in a 0. So what happens is if you get a probability of 0, then the event can occur, which means there's 0% of chance of having it occur. So if you get a probability of 0, that means it can occur, impossible. If you get a probability of 1, so say I got a probability of 5 over 5, that reduces to 1. That's still in between 0 and 1. But what happens is, if you get a probability of 1, that means the event must occur. There's a 100% chance that it will occur. So if you get a probability of 1, it must occur. And so that's your definition. Your first definition is it must lie between 0 and 1, your first rule. And that if it's 0, it can occur. If it's 1, it must occur. And then your second rule is that sum of all the probabilities has to equal, must equal 1. So the sum of all the probabilities has to equal 1. And so what that means is if I had three red marbles and 2 blue marbles, then the probability of the red marble would be 3 over 5. And then the probability of the blue marble would be 2 over 5. So when you add all the probabilities together for the problem, it has to equal 1. If you wind up with 1.2, then it's not valid. If you wind up with 0.9, it's not valid. When you add up all the probabilities for the problem, it must equal 1. And so the sum of all the probabilities must equal 1. And for each event, each probability itself has to be between 0 and 1. So those are your 2 rules. Okay, so they may give you some problems, like they'll throw up something like 0.4, 0.1, and 0.5. So they'll throw these up there and say, okay, is this valid or not? So the first thing is, do these probabilities fit the first rule? Are they between 0 and 1? 0.4 is between 0 and 1, so that checks the first rule. 0.1 is between 0 and 1, that checks the first rule. 0.5 is between 0 and 1, so that checks the first rule. And so the first rule's checked. The second rule says the sum of all these has to equal 1. So when I add 0.4 plus 0.1 plus 0.5, I must equal 1. And so when I do that, 0.4 plus 0.1 is 0.5, 0.5 plus 0.5 is 1. And so that checks too. So since both of these rules check, I can say that those are valid probabilities. So a couple ways you could end up not getting probabilities that work. For example, if I change this to 0.6, same problem. 0.6 is between 0 and 1, 0.1 is, and 0.5 is, so it checks this first part. However, when I add 0.6, 0.1, and 0.5, I end up with a number greater than 1. I get like 7 plus 5, 12, 1.2. And so since 1.2 is bigger than 1, that would mean that is not valid because it doesn't recognize that second rule. Okay, another way they could do it is they could give you something like 1.2 as a probability. Well, if you had 1.2 as a probability, then it would not fall between 0 and 1. It's bigger than 1, and so that would fail the first one. If they give you a negative probability, then that's not between 0 and 1, so that wouldn't work. And so basically, you just have to make sure that each of these 2 rules are satisfied for it to be a valid probabilities. So that'll get you through those type problems. So looking at the actual how we do these, you have a couple definitions. You have mutually exclusive. Mutually exclusive, the definition for that is an event A and event B are mutually exclusive if the occurrence of event A makes the occurrence of event B impossible. Either one or the other can take place, but not both. So in other words, if I had a blue marble and a red marble, and I'm choosing these probabilities, and I can do one, I can choose one, and choosing the blue marble doesn't mess up choosing the red one, or vice versa, then it's mutually exclusive. And so mutually exclusive just means that these events of A and B, the occurrence of this A and B makes the occurrence of event B impossible, then that would be mutually exclusive. And so how you do mutually exclusive ones is you're going to be adding the events together. And so let's just look at a couple. If I did up here on the board 2 green, 5 blue, and we'll do 3 red. So those are my marbles. I have 2 green marbles, 5 blue marbles, and 3 red marbles. Okay? If I just want to know the straight probability of one of them. So if I just wanted to know what P of blue would be. This is number one, what P of blue would be. So the P of blue. Then I'll look and say, okay, what are the number of successful? What are the numbers that I'm looking at? How many of them are blue, in other words? And so I have 5 blue ones, so that becomes the top number. Now, the bottom number is number of possible. That tells you the total number of marbles that we actually had. And so that would be 2 plus 5 is 7, plus 3 is 10. So your fraction would be 5 over 10, which would be 1/2. So the probability of choosing a blue marble would be 1 out of 2, 1 over 2, or 0.5 if you want to write it as a decimal. So that's how you choose it for one event. So that's how you just do it if it's one event. Now, the mutually exclusive just adds a next step to that. And if it's mutually exclusive, which means I can choose, if I choose a red marble, that means I didn't choose a blue marble and vice versa. Then that would be A or B, you just add the 2 probabilities. And so, number 2, I can do what's the probability of choosing a blue marble or a red marble. So, blue marble or a red marble. So, since choosing a blue marble makes it impossible for me to choose a red marble, and by choosing a red marble, it makes it impossible for me to choose a blue marble, those are mutually exclusive. And so I'm just going to do the probability of the first event plus the probability of the second event. So we already did the probability of the blue. So we said that was 1/2. So we did 5 over 10 and got 1/2. So the probability of blue was 1/2. Plus the probability of the red. Well, I had 3 red. So plus 3 over 10. There's still 10 marbles, and the red was 3. So I get 5 over 10 plus 3 over 10. And then I'm just going to add those 2 fractions. When you add fractions, you add the numerators together, and the denominator stays the same. And so I'm just going to add 5 plus 3. That's 8 over 10, which would reduce to 4 over 5, or 0.8. So any 4 over 5 or 0.8 would work. So the probability of choosing a blue or a red marble was 4 over 5 or 0.8. And so notice all we did was we did the probability of the blue, and then we added the probability of the red. So you just add the 2 events together. And so that's if it's mutually exclusive, which means doing one means you can't do the other. If I choose a blue, I can't choose a red. If I choose a red, I can't choose a blue. And so that's what makes it mutually exclusive. So that's pretty straightforward. It's just the number of successful, the number that you're looking at, the number of blues over the total number, then the number of reds over the total number, and then add the 2 together. The second type problem is going to deal with something that is not mutually exclusive. So it's not mutually exclusive. And so if it's not mutually exclusive, it means that there's one that falls into both categories. So probability of A or B at that point would be the probability of A plus probability of B, the same starting point, but you have to subtract off how many occurred twice, and so the probability of A and B. And so one that's not mutually exclusive, the top problem, would be like if we were in our class, we had 5 students, we had how many, or 6 of us together, so we had 6 total. How many of us were there? There were 5 boys and 1 girl, and then we had 1 teacher. So they gave us this list, and I wanted to know what is the probability if someone came into the room randomly and just randomly said, I need to talk to you. What is the probability that that person would be a boy and that person would be a teacher? So what is the probability of a boy or teacher? Okay, so looking at our thing, what we have to decide is if it's mutually exclusive or not. Remember, mutually exclusive means choosing one means it's impossible for the other. So my question is, if I chose a boy, would that make it impossible for me to also choose a teacher? No. It would not make it impossible because one of the boys, I am a teacher, so we know that. What happens here is that since the boy and the teacher, I'm both a boy and a teacher, I fall into both categories. So you have to account for that. And so what happens is, we're just going to do the probability of the boys and add them with the probabilities of the teacher, the same way we would have before. So you would do the probabilities of boys would be 5 over 6. So the P of boy would be 5 over 6. All right, the teachers, there was one teacher. So that would be 1 over 6. Okay? But there's a boy that is a teacher. So that's where you have to subtract off the P of A and B. So how many of them fall into both the boy category and the teacher category? And so that, of course, would be 1 over 6. And so you have to subtract off 1 over 6 out here. And so that's how you do it. You're just going to do the probability of the boy and the teacher and then work it through. And so this problem would wind up being 5 over 6, 1 over 6, and so it would wind up being just 5 over 6 from the start. And so that would tell you, that would be the probability of someone coming in and choosing a boy or a teacher would be 5 over 6. And so these two numbers are not always going to be identical. They sometimes are, sometimes aren't, but that's how it's going to work. And so the idea here is the difference between mutually exclusive, which means you can't be choosing one means it's impossible for the other. So if I chose a red marble, it's impossible for me to then choose a blue marble at the same time. But here, if I chose a boy, I could be choosing a teacher. Or if I chose a teacher, I could be choosing would be choosing a boy. And so you have to account for that, which is why you subtract it off on the end of how many are in that category. And so that's pretty much the lesson there. What we're going to do next here is just give y'all some problems. And so your homework is going to be page 395, 1 through 5. So just kind of walking you through it real quick. Number 1 and 2 says determine whether each group of probabilities is valid. So number 1 and 2, you're just telling me whether it's valid if it meets these rules. If it is valid, you just put valid. If it's not valid, you tell me which one. So if it's not valid because one of them is bigger than 1, say it's not because it doesn't fit this rule. If you add them all together and it's bigger than 1 or smaller than 1 or whatever, or smaller than 0, or bigger than 1, then that wouldn't fit this one. And so just see if it's valid or not, then tell me why it's not valid if it's not. All right, 2 through 5, basically they give you the, you're choosing different things, and so you're going to do, you're just going to do the probability of them, and then they wanted to change it to a decimal at the end. And so just keep in mind there, if you're doing a simple probability, it's just the number that are there over the total number. If you're doing how many of this or that, then if they're mutually exclusive, you just add the two probabilities together. You always still do this first. That's how you always do it, no matter whether it's the mutually exclusive or the not mutually exclusive. You always do the probability of one of them, then you do the probability of the other one. Just you have to remember, if it's not mutually exclusive, if choosing one makes it possible to be in both categories, then you have to subtract off how many are in both categories there again, the probability of that. And so that should get you started. If you have any questions, ask me. So that is the lesson. So just keep working and we'll kind of pick it up moving through. And so just make sure again, it's important because I can't see you to know what you're getting and what you're not getting. But make sure if you have questions, you get up with me and I can walk you through the stuff. Outside of that though, there's not much else to that lesson. Just make sure we have the rules down and we know the difference between mutually exclusive and not mutually exclusive.